Hi, for this problem, even though this is a chess problem, I'm actually not emphasize how to solve those chess problem. There are a few videos already made in the playlist about chess. And however, what I'm focusing on for this video is talking about how to fill up this required diameter and the changing length, because that's some new concept here. So imagine if you have already solved every single member, find their force. So imagine you already solved all those members and find their force. And for this problem, they said this is made of material. This member is made of material of allowable stress is 28 ksi. So stress, we're going to use this sigma. Stress, we know stress is basically the pressure. The pressure is force over area, okay? And this is, they said this cross-section of this member, each member of those is going to be a circular cross-section. So area will be pi r square or pi d square over 4, d here being diameter, right? And the force. And for my problem, the allowable stress is 28 ksi, which is kilopound per square inch. So it's 28,000 pound per square inch. So in that situation, if I already figure out this column, everything, the force here, if I want to just figure out the diameter, then that would be easy, right? This force is known, so this diameter, pi d squared over 4 times my 28,000, it's going to be equals to the force we calculated. Assume the force you calculated is going to be in a unit of pound, and this is in unit of psi, pound per square inch. Then in that situation, your d, what you're going to about to calculate, d is going to be in a unit in inch here. Then how do we solve that? It's pretty easy. So it's just going to be the force times, so basically d is going to be square root of 4 times force, then divided by 28,000, then divided by pi for my situation, right? For my value. So that will help you to solve everything here. Once you know the force, you can find the diameter. Then the last column is changing in length. And this is some other new concept we need to just quickly go over. You're going to learn more in strength material. We're going to create this stress strain curve. Stress strain curve. And y-axis is the stress and x-axis is strain. It's epsilon. Strain is going to be the change in length over original length. So make a note, this is original length. So what's the original length for example, DE? That's going to be B, right? What's the original length for AB? That's going to be A. Okay. So knowing that, we know the stress already. We already get it. Then we have this relationship. Stress and strain, they're going to be linear. And the slope of that is going to be this elastic modulus, which they give us here. So knowing that, E, elastic modulus, for mine is 28,000 ksi. That's going to be my stress. That's given, this 28 ksi over this changing length, over this strain. And we know the strain is changing length over original length. So knowing that, if we were trying to just solve this delta L, because that's the only variable, and that's not too bad, right? Delta L over L naught, that's original length, times is 28,000, that's elastic modulus. That's going to be equal to my stress, 28 ksi. So they both have ksi, and then you know they canceled out. and this is changing length, which is in meter or inch. Here likely it's inch, and then original length is inch, so that canceled out. Okay, so we'll get our delta L in unit of inch, and that will be equal to, for this situation, will be 28 KSI times original length divided by 28,000. So for every single column, for example AB, as long as you figure out the original length, right, L naught for AB, which is A, then you can go ahead and solve this without, so you can get this column without getting force correct, because it's just this equation right here. All right, hopefully this helps, and I'll see you next time. Bye.